So this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through applications of trigonometry. Specifically, I'm going to go through angles of elevation and depression. So let's look at an example in which we can learn all these concepts. So we'll have a go at this question. A person stands 20 meters from the base of the building. The angle of elevation to the top of the building is 30 degrees. And we will use trigonometry to find the height of the building. So if you get a worded question like that and you're not given a diagram, you need to draw one. So let's do that. So we have a person standing 20 meters from the base of the building. We're not told the person's height, so it doesn't matter. So buildings are like at right angles to the ground. So this over here is the building, right? Now, trigonometry always involves right-angled triangles, so we need to make this into a right-angled triangle. Otherwise, we're going to have no chance of solving the question. So what's this part about angles of elevation and depression? So elevation means up. Depression, we're not talking about like feeling depressed, we're talking about down. So the angle of elevation is the angle made when you're looking up at something. It's this angle in here. It's always the angle made with the horizontal. So that is angle of elevation. Again, we're not actually worried about the height of the person. So it's the angle made between the person and the top of the building. The angle made from the person going up to the top of the building. Angle of elevation is up. So the angle of depression would actually be this one here. Again, it's the angle made with the horizontal. So this would be the angle from the top of the building going down to the person. So because these two angles, although they're different concepts, they're actually alternate because we have some parallel lines. They're always equal. So if the angle of elevation is 30 degrees, as it says here, the angle of depression would also be 30 degrees. So remember, angle of elevation is the angle looking up at something. Angle of depression is the angle looking down at something. And it's for both of them, it's always the angle made with the horizontal. Horizontal, of course, means going across. Okay, so this is the angle made with the horizontal. This is the angle made with the horizontal. So now that we've got all that down pat, we know what angles of elevation, angles of depression are. What we can see here is we have a 3D problem being represented in a 2D triangle. We have here a right-angled triangle. Sorry that it's poorly drawn. We have a side, we have an angle. We can find either of the other sides. So it says we want to find the height of the building. Let's call it x. I want to find x. So I have a right-angled triangle. I know the adjacent. I want to find the opposite. I can just use tan for that. So I set up my equation. Tan of angle equals opposite over adjacent. So remember, if the thing you want to find is on top, you times. So x in this case would be 20 times tan 30. And remember, you have to have your calculator in degrees mode. So the answer I get to 2 decimal places is about 11.55. Because this is meters, my answer would be in meters. So the height of the building would be 11.55 meters. How cool is that? We didn't even need to measure the height of the building. We can just use maths to figure it out. All right, now I'm going to show you another question. This time we'll calculate the angle of depression, but don't fear, it's not as complicated as it sounds. All of these is just about drawing a right-angled triangle and finding an unknown side or angle, as we've done in previous lessons. So we'll now have a go at this question here. So the distance from the top of the cliff to a swimmer is 40 meters. The cliff is 15 meters tall. We will calculate the angle of depression from the cliff to the swimmer. So again, worded problem, not given a diagram. Let's draw one. So we have a cliff. This will be my cliff. And the cliff is 15 meters tall, as it said in the question. So from the top of the cliff to a swimmer down here, I'll just put S for swimmer, that distance we're told is 40 meters. So I need to make this into a right-angled triangle, as I do here. So now that it's a right angle triangle, I can use trigonometry. Now, I want to find the angle of depression. So remember, the angle of depression is the angle looking down. It's the angle made with the horizontal. So I can draw a horizontal line. I'm actually looking for this angle here, which I'll call theta. Now, you might be thinking, well, how can I find theta, right? Because it's outside the triangle. Well, there's two ways. I can find this angle here and subtract theta from 90 degrees, or, and the reason is, right, because these are parallel, so if this angle here is 90 degrees, this angle here will be 90 degrees. Or the other thing I can do is find this angle here, because this is the angle of elevation from the swimmer to the top of the cliff. Remember, the angle of elevation and angle of depression are equal to each other. So I'm going to do it the second way. I'm going to find this angle here, which is equal to this angle. So how do I find that? Well, that's easy. I just use the same processes I've been using in the last few lessons. So theta equals, we have opposite, and hypotenuse, we use sine. So it'll just be sine inverse of opposite over hypotenuse. Again, make sure your calculator's in degrees mode or you'll get the wrong answer. So I get the angle of about 22 degrees to the nearest degree. So this angle is 22 degrees, therefore this angle, the angle of depression, would be 22 degrees. So that is the answer to it. The angle of depression from the top of the cliff to the swimmer is about 22 degrees. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.